Hi, today we are going to look at our chain rule. So if we have a function g is differentiable at x, and we have another function f which is differentiable at g, then f of g of x is differentiable. So essentially our chain rule deals with composite functions. Now often we can break something like this up, a composite function. So if we have y is equal to f of g of x, we can break that into y equals f of u, where u is equal to g of x, which gives us a derivative of y is equal to our derivative of y with respect to u times our derivative of u with respect to x. Or another way of writing this is our derivative of f of g of x is equal to our derivative of f of x with g of x in it times our derivative of g of x. So we'll do some examples where we break function y equals f of g of x into two separate functions. So y equals a function that relies on u and another function that's u is equal to g of x. So for example, find the functions y equals f of u and u equals g of x so that the following functions can be expressed as y equals f of g of x. Then we're going to find the derivative of y with respect to u and the derivative of u with respect to x. And then we're going to find dy over dx in terms of x. And we're doing that for both these functions on this page. So we've got y equals 2x squared plus 3 inside a square root. So first part is find the functions y equals f of u and u equals g of x. So in this case, our outer function, which is represented by this one, would be the square root. So we'd have y is equal to the square root of u. So here's our function. It is relying on the variable u. Now, our function u is what's inside this. So we're going to say that u is equal to 2x squared plus 3. B is figuring out what dy over du is and what du over dx is. So if we have a derivative of y with respect to x, or sorry, with respect to u, if we have the derivative of a square root, that's we know is 1 over 2 times that square root. While we know that du over dx is going to be the derivative of this function with respect to x, that's just going to be 4x. Now from that previous page, we know that dy over dx is equal to dy over du times du over dx. So therefore, dy over du was 1 over 2 root u times our du over dx, which was 4x. So this is going to be 4x over 2 root u. Now we need to go through and simplify this. For one thing, we can reduce these, so that's just going to be 2x. And the other thing is we know u is 2x squared plus 3. So we've got square root of 2x squared plus 3. Okay, so we're going to do the same thing with this one. So we need to break it up into a function for y and a function for u. So our function for y, that's going to be in terms of u, would be as outer functions. So it would be our going to a power of 17. So y equals u to power 17. While u is going to be this inner function, which is 3x squared plus 5. Now dy over du is going to be the derivative of this, so that would be 17 u to power of 16. While du of dx would be the derivative of this, so that would be 6x. Now, the overall derivative of this, dy over dx, is equal to dy over du times du over dx. So dy over du was 17 u to power of 16, and then that's times by the 6x, which would be our du dx. Now we can probably multiply this 17 by the 6x, which gives us 102x, and then we've got times u to power of 16. So that would be 102x times our u, which we said was 3x squared plus 5 to the power of 16. Okay, next example. In this case, they've always split up a function for us. Now we don't know what the original is, but we're given y in terms of u and u in terms of x. So we've got y equals u to the power of 10 plus u to the power of 5 plus 2, and we're given u equals 1 minus 3x squared, and we want to find dy over dx when x equals 1. So whenever we have this vertical line that's to our dy over dx, and then it has a value down here, it's telling us what value we're putting in for our variable. So first thing I would do is find the derivatives of each of these. So dy over du is going to be 10u to the power of 9 plus 5u to the power of 4. And then du over dx is going to be negative 6x. Now, dy over dx, we know is dy over du times du over dx. So that's going to give us 10u to the power of 9 plus 5u to the power of 4 times negative 6x. That tells us dy over dx is 10 times u, which was 1 minus 3x squared, to the power of 9, plus 5 times 1 minus 3x squared to the power of 4 times negative 6x. So this is our dy over dx. Now we want to find dy over dx when x is 1. So that is 10 times 1 minus 3 times 1 squared to the power of 9 plus 5 times 1 minus 3 times 1 squared to the power of 4 times negative 6 times 1. So we'll go through and we'll simplify this. That gives us 10 times 1 minus, essentially 1 squared is 1 times negative 3 would be negative 3. So we'd have 1 minus 3, which is negative 2, and then negative 2 to the power of 9 gives us negative 512. Then we have plus 5 times, well, we determined as negative 2. Negative 2 to the power of 4 is 16. And then we're multiplying this by negative 6. So that gives us negative, we'll multiply by 10 by this, so negative 5,120 plus 80 times negative 6. So that should give us 30,240. Now, so far we've only looked for if we have a composite function involving just two functions, but of course composite functions can have more than two functions. So if, for example, we had f of g of h of x, as long as all three of those functions are differentiable at x, then the overall function is differentiable at x. In which case, we then break this down into y is equal to a function that depends on u is equal to a function that depends on t, and t is a function that depends on x. So therefore, we'd have dy over dx is dy over du times du over dt times dt over dx. So find the functions y equals f of u equals g of t, and t equals h of x, so that the function y equals 1 over the cube root of x squared plus x plus 1 can be expressed as y equals f of g of h of x. Once we do that, we're going to find the derivative of each of those functions and then write dy over dx, or our overall derivative, in terms of x. So first one, this first one would be our overall outer function. So that would be this fraction here. So I would say that y is equal to 1 over u. Well, I would say the next function is this one that encompasses all of this inside. So therefore, the next function, which is u is equal to g of t. So therefore, after writing in terms of u and t, so therefore I'd have u equals the cube root of t, which can also be written as t to the power of 1/3. And then I would say t is equal to what's inside that root, so x squared plus x plus 1. Now we want to find the derivatives of each of these. So dy over dx, the derivative of 1 over u is negative 1 over u squared. That, and sorry, I just realized I wrote the wrong thing down here. Dy over, not dx, because we're doing a few, so dy over du. Next, we've got du, and then it's in terms of t, so dy over dt is equal to essentially the derivative of this, so we'd move the 1/3 in front, subtract 1, so to t to negative 2 over 3. Now we may want to write that as a fraction in root, so that would be 1 over 3 times the cube root of t squared. The last derivative is dt over dx. So derivative of this quadratic is just going to be 2x plus 1. Now, our overall derivative dy over dx is going to equal dy over du times du over dt times dt over dx. So that's negative 1 over u squared times du over dt, which was 1 over the cube root, 1 over 3 times the cube root of t squared. And then that's times our derivative of t with respect to x, so 2x plus 1. So simplify this a bit, then start doing some substitution. So this would be the only thing that would end up in our numerator. So we've got negative of 2x plus 1 over 3 times u squared times the cube root of t squared. So we'll start substituting in what we know for u and t. So we know we've got negative 2x plus 1 over 3 times u squared. We know u was the cube root of t. Now, because it's a cube root of t and we're also multiplying it by another cube root of t, here what we might actually want to do is write u in as t to 1 over 3. And then we can always put this one in as times t to the 2 over 3. And of course, this one was being squared because we had the squared there. So that's negative of 2x plus 1 over, if we're squaring an exponent, we multiply, so 3 times 2 to 2/3 times t to 2 to, sorry, t to the power 2/3. Now, in this case, we can then simplify this, so we've got negative of 2x plus 1 over 3, and then from exponent laws, we add these exponents, so t to the power of 4 over 3. Now we might as well substitute in what our t was. Our t was x squared plus x plus 1. I'll just continue this up here. So we've got dy over dx equals negative of 2x plus 1 over 3 times our t, which was x squared plus x plus 1 to power of 4 over 3. Now, depending on if you are allowed to leave as an exponent or not, this can also be written as negative 2x plus 1 over 3 times the cube root of x squared plus x plus 1 to the power of 4. Now this also brings us to our square root rule, which essentially says that if we are taking the derivative of the square root of a function, that's the same as 1 over 2 times the square root of a function times the derivative of a function. So this can save us some time expanding things out with our chain rule. So for example, we're asked to differentiate x square root of x to the power 6 plus 5x to the power 4 plus 3x squared plus 6. Or if we use our chain rule, we can see that we have essentially this outer function with this inner function. But with the square root rule, we can go directly to coming up with our equation. Because essentially on that previous page, if we had d over dx of the square root of f of x, we know that that's equal to 1 over 2 square root of f of x times f prime x, or derivative of f of x. So if we have this, we know its derivative is just going to be 1 over 2 times the square root that we had here. So x to the 6 plus 5x to the 4 plus 3x squared plus 6. And then that's times our derivative of what was inside. So that's going to be 6x to the power of 5. Moving that out front gives us plus 20x cubed. Moving this gives us plus 6x. And then we will move this to our numerator. So we've got equals 6x to the power of 5 plus 20x cubed plus 6x all over 2 times the square root of x to the 6 plus 5x to the 4 plus 3x squared plus 6. Now you'll notice is every number up here is a multiple of 2, and we're dividing by 2 here, so we can simplify this a bit, so it becomes 3x to the power of 5 plus 10x cubed plus 3x all over our square root of x to the power of 6 plus 5x to the power of 4 plus 3x squared plus 6.